So in our last notes, we were talking about, we left off talking about the quadrants, where the sine and cosine and tangent are positive and negative. And so remember that the cosine is the x value and the sine is the y value. And those are in alphabetical order, I guess, to remember them, right? Cosine comes before sine. So cosine is the x, sine is the y. And so we talked about what quadrants, what would be positive where. So we're going to kind of continue down that theme. So if we look down here, we want to determine what quadrant and what quadrant theta is in, given the following conditions. So we're trying to figure out where is theta. Given that the cosine is positive. So I think about the unit circle, the cosine, because that's the x, is positive in quadrants 1 and 2. Okay, so the cosine is positive in quadrants 1 and 2, but it has to satisfy both conditions. The cotangent, which is the tangent flipped over, and so that doesn't change positive and negative when you flip something over. So the cotangent and tangent are positive in quadrants 1 and 3. And we want our answer to satisfy both conditions. So if theta satisfies, if theta has the cosine is positive and the cotangent is positive, well, I know that that satisfies the condition in quadrant 1, and they both satisfy the condition in quadrant 1. Therefore, theta has to be in the first quadrant, okay? So for part B, we have the sine is positive, okay, greater than 0. So the sine is positive in quadrants 1 and 2. Remember, sine is the y value, right? The cotangent is negative. Notice they flip the sign. Cotangent is negative in quadrants 2 and 4. And so which quadrant satisfies both conditions? Well, that would be quadrant 2. So theta must be in quadrant 2. All right, so we're just determining the quadrant on those first. Any questions on the first couple? I'll do one more. All right, which one do you want, C or D? All right, D. So we have the tangent in D. The tangent is negative, less than 0. And so the tangent is negative in quadrants 2 and 4. And the sine is positive in quadrants 1 and 2. Therefore, we must be in quadrant 2 because that satisfies both conditions. Because knowing, yes, Olivia.
So when it says like cotangent or secant or cosecant, can we treat it like it would be like tangent or sine as in like positive and negative?
Perfect. Yes, great question. If you have any of the reciprocal functions like cotangent, secant, or cosecant, you can just think of its counterpart, the sine, the cosine, and the tangent, as positive or negative. Because when you take a number and flip it over, it does not change from positive to negative or vice versa. So, for example, in this one, when we had cotangent, I just think of that as tangent in terms of quadrants. Okay, so yes, very well put. Any other questions? All right, so we're going to then use that information along with what we know about reference angles. And so I'm going to rewrite what I have up on the board there. Remember that if we had an XY axis, and the unit circle here. I'm just going to put in the three most famous angles at 30 degrees, 45 degrees, and 90 degrees. And I'll put their coordinates. Oh, I said 90 degrees. That's not right, guys. Sorry. That's not 90 degrees. 90 degrees will be straight up. Sorry, I gotta redo a little bit of this guy here. That's 60 degrees. Okay, so I have 30, 45, and 60 degrees. And at 60 degrees, my coordinates are 1/2 √3/2. At 45 degrees, I have √2/2 and √2/2. And at 30 degrees, I have √3/2, 1/2. Because if I can combine this information of my reference angles along with knowing what quadrant I'm in, I should be able to determine any of or evaluate any of those trig functions. So it would be really helpful to know this stuff. And one way that I help remember these numbers are I look at the top left of each fraction, like 1, 2, 3. Okay, for 1/2 √2/2 and √3/2. So if you think it's easy as 1, 2, 3, maybe then you could remember the other ones kind of fall in line. Okay. All right, but let's take a look at part A, where we want to find the cosine of 135 degrees. So I would first think 135 degrees is in which quadrant? Well, that would be the second quadrant because it's less than 180. But greater than 90. So I'm in the second quadrant and I'm 45 degrees less than 180. So if I had, again, here's my angle. Okay, that's 45 degrees. That's 90 degrees. 135 degrees would be here. So all I need to do is know that it's counterpart is the 45-degree angle, or its reference angle is 45 degrees. The cosine is the x value. So my answer is going to be this guy in the second quadrant. Because it's an x, it's going to be negative, so it's going to be negative √2/2. Next, the sine of 135 degrees. Well, sine is the y value, negative 135 degrees. Now remember, it's a negative angle. So that means that most angles go this way, go counterclockwise. But if it's a negative angle and going this way, 135 degrees, so that's negative 90, that would be negative 135. Giving me a reference angle of 45. So since my reference angle is 45, sine is the y value, it's going to be that guy down in the third quadrant, so it will be negative. So it will be negative √2/2. All right, if I want to find the tangent of 120, first, what quadrant is 120 degrees in? Second, very good. It's in the second quadrant. So I'm going to look here, and here's my My angle, that's 90 degrees, 120, would be in the second quadrant. It'd be 60 degrees away from 180, meaning my reference angle is 60 degrees. The tangent is the sine over the cosine. The sine is the y value, which is √3/2. Okay, and I'm again using this coordinate. But I'm in the second quadrant, so my cosine is negative. So my cosine will be -1/2. So to clean that guy up, remember if we're dividing by 2 and dividing by 2, we can just get rid of those guys. We have -√3. Yes. Yep. So I'm taking, this is my reference angle, but remember it's 120 degrees, so we are in the second quadrant. And in the second quadrant, my x value will be negative and my y value will be positive. Okay, so just think like to get to that point, I have to go to the left and up. I have to go -x and +y. Okay. All right, any other questions before I do a couple reciprocals? All right, well, to do the reciprocal functions like the cosecant or secant or cotangent, all you do is find the other function, its reciprocal, and then flip it over. So let me grab this unit circle, move it down here, make it a little easier to see. But if I want to find the cosecant of 240, I first need to determine what quadrant I'm in. So 240 is, here's 90, here's 180. And so 240 is going to be somewhere in here because this is 270, right? 270 is straight down. So 240 would be somewhere in here. So how far past 180 did I go? I must have went 60 degrees because 180 plus 60 is 240. So since my reference angle is 60 degrees and the cosecant is the sine flipped over, it's going to be the y value in the third quadrant flipped over. So the y value will be negative. And I'm going to flip that over. So that's going to be -2 over √3. Now I'm going to clean that up in just a second, rationalize it, but are there any questions where we got that? Okay, again, third quadrant, so it's got to be negative. It's the sine, it's the y value flipped over. So now I need to multiply top and bottom by √3 over √3, giving me a grand total of -2 √3 all over 3 for our cosecant of 240. All right, I'm going to move to the next section. We're trying to find trig functions here. So it says find the sine and tangent if the cosine is 2/3 and the cotangent is greater than 0. So first thing is, let's figure out what quadrant we're in. Given this information, we can determine what quadrant we're in. We know the cosine is positive, so that means we're either in 1 or 2. I'm sorry, 1 or 4, because the cosine is the x. The cotangent is positive. That means we're either in 1 or 3 because cotangent is sine over cosine. So that means ultimately we must be in quadrant 1. So once I determine what quadrant we're in, I'm gonna draw a triangle. And I drew my triangle in quadrant 1, okay? Here's my theta. It's always towards the origin. Now we know that the cosine is 2/3. So going back to the SOHCAHTOA days, cosine is adjacent over hypotenuse. So the adjacent is 2, the hypotenuse is 3. And so doing a little Pythagorean theorem, I have to find that third side. Okay, so I do like 2 squared plus b squared equals 3 squared. And so that's going to be 9 minus 4 or the square root of 5. Now I haven't even gotten to my question yet, but that's actually kind of the easy part. The hard part is getting all this set up. So I determined what quadrant. I drew my triangle and found the sides. And now I just want to write the ratios. So my answers, it says find the sine of theta. Well, the sine is the opposite over hypotenuse, which is root 5 over 3. And the tangent, remember, is going to be opposite over adjacent. So the tangent of theta is root 5 over 2. So we have found our sine and our tangent of theta. Again, we found the on the quadrant first, then drew our triangle, and then wrote our ratios. So let's do the same thing for part B. Let's first determine what quadrant we're in. If the sine is 1/2, meaning it's a positive number, remember the sine is the y value, so that means it's in either 1 or 2. And the cotangent is negative, that means it's either in 2 or 4. Therefore, angle theta has to be in quadrant 2. Okay, theta has to be in quadrant 2 from the given information. So I think that's kind of the hard part, is determining the quadrant and then making sure that we draw our picture correctly. We're always making it perpendicular to the x-axis. Because now I just want to fill in that the sine is 1/2, because sine is opposite over hypotenuse. And now I need to find that third side here. So I could do 1 squared plus b squared equals 2 squared. And so that's going to be the square root of 3. But don't miss this. I put a little negative in front of that. Because remember, we're in the second quadrant. So starting at the origin, I want to go to the left root 3 and up 1. So that's the hard part. And now we want to write our ratios. secant is the cosine flipped over. Cosine's adjacent over hypotenuse, so the secant is hypotenuse over adjacent. So the hypotenuse is 2, and the adjacent is negative √3. Which then rationalizes into -2 √3 over 3. The tangent, yes.
How does that negative square?
This here, that part. Yeah, so the secant, remember, is the cosine flipped over. The cosine is the adjacent over the hypotenuse. So the secant is the hypotenuse over the adjacent. Make sense? Good. Good question. Any other questions? All right, let's finish it off with the tangent. So tangent of theta, tangent's opposites over adjacent, so it's 1 over -√3, which again rationalizes into -√3 over 3. All right, one more thing to get done here. A couple more questions before I move on. Any other questions? All right, well, let's go down to number 7 then, okay? Problem number 7, again, is a quadrant type question. It's saying for each of the following values of theta over the interval from 0 to 360, we want to find when is the cosine equal to √3 over 2. You know, I'm going to go back up here and grab this unit circle, and drag it down here because it's so important to help me determine at what angle the cosine would be √3 over 2. Well, the cosine, remember, is the x value. So can't erase that blue blob there. So I'm looking for when is the x value √3 over 2? Well, right here at 30 degrees, that's one of my answers, but just one of my answers though. Because the cosine, which is the x value, would also be √3 over 2 down here with a reference angle of 30, but in the 4th quadrant. So that would be 330 degrees. Because it would be 30 degrees shy of 360. All right. Let's do the last one here. Is the sine the x or the y value? Y value, right? Sine is the y value. So we want to know for the next one, I'll change my color up again. When is the y value -√2 over 2? Well, the y's are negative in the 3rd and 4th quadrant. So it's going to be this guy, but it's going to be in the 3rd and 4th quadrants. So if my reference angle is 45 degrees, but I want to be in the 3rd quadrant, 180 plus 45 is 225 degrees. And if my reference angle is 45 degrees and I'm in the fourth quadrant, well, 360 minus 45 would be 315 degrees. So knowing the quadrants and a little mental math of adding and subtracting, we're able to determine those quadrants. All right, any questions on that?